Hi, thank you very much for giving me this opportunity to talk about our project. New Sun is a prototype simulator that has been developed under the project funded by Gates Foundation. The project is modeling the next generation of sanitation systems. What would be this next generation of sanitation systems are those that use less water, less, and recover resources and making fertilizers or producing energy using human excreta. My presentation today, I'm going to talk about briefly about the simulator. So as I mentioned initially, the aim of the simulator is to model excreta flux, so including resources fluxes such as nitrogen, phosphorus, also BOD or COD. The prototype, the new Sun prototype can simulate from the household where the waste is produced up to the final disposal or reuse of those resources. And obviously this tool aims to assist on decision making. So the main users of the simulator would be engineers and consultants working on the sanitation sector. Also, this prototype or this once developed will also benefit those funders, such investors or banks that give money or lend money for sanitation implementation as well. Currently, we have some users of the tool. The only users at the moment are University College London and also Cambridge University. The International Water Management Institute also it's using. KwaZulu-Natal University, Professor Chris Buckley also has had opportunity to use this tool. And there is obviously increased interest on from part of many people looking for the tool when would be available. The main outputs of this tool are the waste, as I said, wastewater or the sludge, the nutrients such as carbon, phosphorus, nitrogen. Also, we are simulating resource economy such as energy consumption or generation, capex, opex, and also revenue. Because through the simulation, we can comparing the technologies available there, we can then have an idea of which one can give us more revenue or can produce more energy or can be more efficient on treating the waste. The next slides, I'm going to show you some of the examples of the outputs. Can you pass the next slide, please? As example one, these slides show the system setup. The model is very simple to use, so the user, people like you and me, can easily, with some knowledge and training on the use of the program, can easily set up the sanitation chain that you want to simulate. So you start, for example, on example A in these slides. You set you create a block, we call blocks or sunk. This is an example of sunk diagrams. You create a block for the settlement representing how many people is going to use that system, and then you create another block of the toilet, another block of which is the technology that is collecting your waste from the toilet. For example, in A, show a septic tank, and then the following blocks will be related to transport and also further treatment and final reuse, treatment or final reuse or disposal. For example, on B, you can see that it's the same system, low flush toilet followed by septic tank, but there, what it's been simulating is that the use of a vortex bioreactor to further treat the effluent of the septic tank, and the sludge is being transported to a pyrolysis process to then produce biochar, bio-oil, and gas. The final one, letter C, shows that instead of going through a septic tank, the wastewater is being collected by the piping system and then going to an anaerobic digester that will then produce biogas, and then also can be used, the effluent of the anaerobic digester would be used in irrigation and also in soil conditioning. Next slide, please. Example 2 shows a simulation of the nitrogen fluxes. So you have there another example, a system using system flush toilet. The first one followed by septic tank, the second one by our sewer systems, and the second and third one as well. The sewage is collected and go to an anaerobic digester again, and the third one instead of going to the anaerobic digester, go to a trickling filter. As you can see, the user can then compare which would be better in this case, if it's an anaerobic digester or if it's the trickling filter, through the values, because of the circuit diagram, as you can see, there are some numbers. Those numbers inside those lines that are linking blocks, they represent the amount of nitrogen, in this case in kilos per day, that is being transported from one unit to another unit. Next slide, please. So this is another example of an output representing energy fluxes for a system that is consisted of VIP latrines, and then goes to a single pit, and then is collected, from the pits, the sludge is collected through for a pyrolysis system where we're going to produce biochar. This is just the setup, is this energy flux. As you can see, the arrows where we are simulating here energy that is generated and produced. So you can see that the pyrolysis system requires some energy to be operated, but on the other hand, it also producing amount of biochar, bio-oil, and gas. So at the end, you can replace, or obviously this on this chain, any of the components, and see which one would be the best option that you would like to use, or at least to help you to take a decision about the system. Next slide, please. Output number 4 is just to illustrate the potential of representing CAPEX. We have representing here only CAPEX. Obviously, we can also print out the OPEX, the operational cost. This is a system using urine diversion dry toilets. Is the conventional way that goes to a soak pit, or then goes to the soil. As you can see again, the CAPEX, the costs are represented by those orange arrows going down. So you can see that in this case, the cost is mainly from the dehydrating valves. Next slide, please. Example 4 is, it has been prepared by Luca Di Mario, a PhD student from Cambridge University, who is using SuSanA to investigate, do business models in Bangalore and also in Lima. he has been creating blocks that also simulate the solid waste. So here, this is an example of collection of waste produced by domestic hotels and restaurants, and also from markets, fruit and vegetable markets. And what he wants to see is the potential that can maybe use this organic waste to be used in future for generating energy or doing something else. So the good thing about NewSun is that it gives us also opportunities to create any blocks we want, the user wants, if it's a solid waste. And then existing system, you can create the existing system and then also simulate the options, the different scenarios the user would like to have. Next slide, please. The next slide is just showing the gaps and constraints about the model. As you can see, it's a prototype version. It needs refinement and finalization. It is one-dimension model. At the moment, it does not have a GIS interface, but with a further development, it is possible to incorporate GIS. Unfortunately, because of the lack of data, we have been using most of the parameters and values that we use as input in NewSun. They come from literature. In particular, we lack a lot of data information on cost and energy information of the systems. Most of those information, they are not easily available on the internet. At the moment, for example, we are looking for costs and also energy values for systems that produce biochar and also anaerobic digestion. That there are several types of anaerobic digestion. So if the people from SuSanA have those values, I would be very happy to have those to simulate on our system. And obviously, the model also needs some calibration, and we are planning to do calibration of the tool once we identify a place where most of those values that NewSun require are available, and also we will need to collect further values for the specific area. So thank you very much for listening to me, and I hope you will you have enjoyed knowing a little bit about NewSun.
So thank you very much, Luiza, for that great presentation of the material flow within sanitation systems. So just a few questions for you. One is the input values, quantities, situations, costs that you have in your flow diagrams. How do you acquire these values? And another question is on nitrogen and phosphorus flow within diversion dry systems. If you've done that kind of a flow, I'd like to know. And then the third question is if you're aware of or you're collaborating with the wash cost project or program that IRC in the Netherlands is running. So, please.
Okay, thank you very much. Thank you very much for your questions. Regarding to the first one, regarding the input values, as I mentioned during my presentation, the values we are using is mainly from literature. So any paper that has been published that using systems like urine diverting toilets or technologies such as anaerobic digestion, and they have values that we need, like production of energy or consumption of energy or efficiency of the decay of the nitrogen or any other information, because NewSun does material flow analysis. So it's very simple. The values we do need is mostly we need what is input, and we need to know what's more or less that's happened there, if it's a percentage or what is the decay, to be able to calculate the output. So because we rely on literature review, And we haven't done any case study to test the model in terms of validation, right? To see if the model is performing correctly. At the moment, the comparison and to see how accurate is our calculations, we are only doing, for example, doing the simulation of an example and trying to find case studies where they are producing, they have systems producing the same sort of outputs we are doing, for example, producing biochar or producing recovering energy through anaerobic digestion. We would see if it's doing the same. Because the main problem as well is when it's scaling up, because most of the new technologies, they are only in small scale. So the scaling up process is completely different. So for those technologies that are new and we don't have them in existing mode, it's going to be more difficult to validate them. It's going to be a long process. Regarding to the other two, I remember third question, the wash. We have been using wash costs, and obviously we would like very much to collaborate with Netherlands, but we are at the moment looking for finance resource that would keep us going more, developing further the model that needs to be further developed and calibrated. And regarding to nitrogen, phosphorus from UDDT, my slide showed only the setup of the system, right? It was showing CAPEX. But I could have shown here what would be for that case that I don't remember by mind, what would be the nitrogen fluxes, what would be the phosphorus fluxes, and what would be the flow, the waste flow fluxes, and any other output, for example, such as pathogens. If you have E. coli or any helminths, for example, you can simulate and plot as well as output. Did I answer your questions? Okay. So thank you very much.
Yeah, have a nice evening and thank you again.
Thank you very much. Thank you, SuSanA, for organizing this for us. I really appreciate.
Thank you very much.
Thank you. Bye. Bye.